Hello, everyone. Today we're going to be talking about slopes of equations. We kind of skipped over this yesterday, and the main reason why is because we are going to talk about it today. So take a second. I want you guys to, as always, start by pausing your video, and I want you to try to answer the Ignite at the top of the page. All right. So whether or not you were able to write anything down in terms of what you remember about slope, the goal for today is really to kind of refresh your memories and or go through maybe you didn't remember a lot of things about slope. So obviously the first thing that we're going to talk about is and yes, this is pretty much the name of the unit. This unit is all about linear equations. And yesterday we kind of skipped over exactly what it was, or we needed to be able to see what it looked like first. So a linear equation, in the simplest terms, it's an equation where any variables are raised to the first power. Usually it implies that we're only talking about x, but you'll see whenever we graph equations, there's usually always an x involved and a y involved. And if you're graphing a linear equation, the x, usually it's specifically just the x, but basically as a rule of thumb, all variables are only raised to the first power. As soon as you start looking at x squareds, x to the thirds, x to the fourths, those create nonlinear equations. And you won't really deal with those until we'll deal with x squareds a little bit second semester, but in Algebra 1, we don't really go beyond that this year. But you will get to that when you guys reach Algebra 2. So obviously the main star of the day is slope. And what exactly is that? So slope, in terms of graphing, slope really refers to kind of the grade of what you're walking on. So like how steep something actually is. So specifically when we talk about slope in terms of lines, the slope of a line is just how steep the line is. Now we're in a second, we're going to talk about like where you find that, how you find it, how we calculate it, all that fun stuff. But specifically when talking about slope, we always use usually the variable m to indicate that something is going to be a slope. There's other ways to obviously talk about it, and actually one of those ways are something called rate of change. And this is something that is another way that it basically means slope. Slope really is two different phrases that we use to talk about it. I could say find the rate of change of this line, and I could also say find the slope of this line, and those questions are really no different. So we're going to start off by just looking at a couple examples and really just determining is it a linear equation and is it not? So when it comes to something being linear, something that there's kind of yes, it's that the variables are raised to the first power, but it sometimes involves a little bit more than just that. X and Y also have to be separate. So what I mean by that is you can't be multiplying an X by a Y. So for example, if I look at example 1, my first step are all of my variables being raised to the first power? And yeah, technically that's totally true. All of my variables are being raised to the first power, so that part's good. But are all variables separate from each other, but using either separated by addition or subtraction or an equal sign? And that actually isn't true. If I look at my X and my Y here, just simply because of the fact that those are being multiplied tells me that no, this is not a linear equation. If we look at example 2, here we have my X is on one side, my Y is on the other. So my variable terms are separated. Are they being raised to the first power? Yeah, they're all being raised to the first power. So what that means is yes, this is a linear equation. Now, if something actually is linear, then we can get into the fun stuff. And I'm gonna let you guys know right now, I'm never gonna make you graph nonlinear things. You'll get to that in some of your later math classes that you guys cover. But when we talk about slope, there's kind of like 4 main slopes that we'll really deal with. We're going to talk about steepness and all of that in just a little bit to find exactly how steep a line is. But usually slopes kind of fall into one of 4 categories. There's a positive slope, There's a negative slope, there's a slope of 0, and there's an undefined slope. So when it comes to slope, just so you guys are always aware, how we read a graph, it's always from left to right. So when we talk about if a graph has a positive slope, it simply means that your line has to be increasing from left to right. So whatever line you have, as long as it's somehow going up, doesn't matter how steep, all of those lines would be considered lines that have positive slopes because the left end of the graph is lower than the right end of the graph. Negative slope is the opposite. Negative slope means your line starts up, and by the time you reach the end of the graph, you're below wherever you started. If you have a slope of 0 simply just means that you're not increasing and you're not decreasing. So I always kind of think of this as like when you're actually like walking. When you walk along like the floor, hopefully it's not having some sort of steepness, especially if it's in your house. In all of your houses, the slope of your floor should be 0. And that just means it's a line that you can essentially just walk across. Okay? I'm not increasing, I'm not decreasing, but I'm also not, I have a slope. It's just, in this case, because I'm not increasing or decreasing, we call that a slope of 0. An undefined slope is Spider-Man's favorite thing to climb. And it is only a line that he can climb. An undefined slope literally means a vertical line. Because this isn't just, is it positive? Is it negative? We don't really know because left to right, it doesn't go from left to right. So when we have an undefined slope, this is always the case for some sort of vertical line. Now we need to get into the fun stuff, and that is how do we actually calculate slope? Well, slope, there's usually one main formula that we're going to use to calculate this. Now, whether it's rate of change or slope, doesn't matter. Remember, those are the same thing. There is a formula that we are going to use, and it's actually called slope formula. All right, so if we're going to write down slope formula, remember now, slope we always use m as the variable that represents slope. So to calculate the slope, you guys will probably maybe remember this, I don't know, let's see. But what we do is we basically take the y values, so whatever the y coordinates are of any 2 points that are on the line. So that's the cool thing about when you're going to calculate slope. What you need are 2 points on any given line. And what we do is we basically subtract the y values. That goes on top. And on the denominator, what we're going to do is we're going to subtract the x values from those different pieces. Now, the reason why we do this is because to really calculate how steep something is, steepness kind of has 2 different directions. If you're going to look at, like, for example, let's look at like our negative slope one from up here. When you're going to calculate how much you're actually decreasing on this one, we have to measure in 2 dimensions. Whatever point we pick on this line, in order to calculate the actual steepness of this, we have to measure kind of like the vertical component, and I have to measure the horizontal movement in order to get to my second point. So when we do the subtraction piece, what this is, when I subtract here, when I subtract my y's and I subtract my x's, that is calculating those different distances. And slope specifically, slope we always measure in that way, because when we talk about slope, we always measure it, we always call it rise over run. We measure kind of like the rise between any 2 given points. That number always goes on top. And then the run always goes on the bottom. Is there a specific reason why we do rise over run or y's over x's? Not necessarily. It's just considered universal to always measure it as rise over run. Sometimes you'll see another way to write this. You could say that little triangle symbol that represents delta. And in math, that just means change. That's why we can use rate of change as a way to talk about slope, because we're calculating the change in the y values, the change in the vertical distance, over the change in the horizontal distance, which is just your x's. So let's actually go about and actually calculate a slope. Let's get into the fun stuff. So for example, for this first problem, if I said in example 3, use the table to find the rate of change, that just tells us that we have to find our slope for this problem. And to find slope, we need to know 2 given points. Now, sometimes I might give you more than what you need. Like in this one, I actually gave you 3 points. I gave you a point here, here, and here. Your job is to just pick any 2 of them. So I'm gonna pick, I don't know, I'm gonna do 276, and maybe we do, I don't know, what do you guys think, 228? What you just found though are your 2 points that we're gonna use to find our slope. And to find the slope, it might help to label our points. So if you guys remember from above, to calculate our points, we have to have 2 different ones. And whatever points you choose, we call them x sub 1, y sub 1, and x sub 2, y sub 2. We just give the x and the y coordinates a name. And the number that goes with it just simply represents the fact that it's part of the same ordered pair. So x1 and y1, it just means that's an x and a y coordinate from one of your given pairs. So if I'm gonna go through here, let's label these then. I'm gonna call this one my x1, y1, just because those are both part of the same ordered pair. You could flip them. You could have made this x sub 2, y sub 2. Honestly, doesn't matter. But I always kind of get in the habit of, at least while we're setting this up, I get in the habit of labeling them. Because what our next step is gonna involve is the actual slope calculation part. To calculate our slope on the numerator, we have to subtract our y values. So let's say we do 76 minus 228. The cool thing about slope is the order doesn't really matter. If I do 76 minus 228, you just have to realize you did your first ordered pair and you're subtracting your second ordered pair. So when you subtract your x's, it has to be the same setup. On the bottom of that, I'm then going to do x sub 1 minus x sub 2. And now we're just gonna go ahead and simplify. So to simplify, I'm gonna take 76 minus 228, and that's gonna leave me with negative 152. On the bottom, I'm gonna do 2 minus 6, which is gonna end up being negative 4. And then, as always with all fractions, we always reduce. So if I actually divide negative 152 divided by negative 4, we get 38, or if you like writing it as 38 over 1, either way, you just found your slope. We're gonna rise 38 and we're gonna run 1. Now, tomorrow we're actually gonna see, or when we look at our next video, we're actually gonna look at how to calculate this on a graph and things like that. But for today, we're just simply focusing on me giving you points and you finding it. So I want you guys to pause your video, and I want you guys to try finding the slope between these 2 points and go. All right, hopefully you got your slope of negative 3 over 4. Now, keep in mind of the fact that there's actually another way to solve this one. Because think about it, at the end of the day, the top number represents the rise, so how far vertically you're moving, and the bottom number represents your run. So a cool thing, if you have a graph actually, you can actually calculate this on the graph. If my goal is to calculate the rise over the run piece, you can do that also just by counting, if that's something that's easier for you. So if I need to go from this point up here, 0, 7, down to 4, 4, I already know the fact that my line, since it's going down and to the right, I knew for a fact that my slope was going to be negative. Now, depending on what number you choose, let's check this out and let's see why. If we start at the leftmost point, we can always calculate my rise and my run separately. Well, in order to get down to this level, how far down do I have to actually go? If I have to go down to 3. So because I'm going down, I'm rising negative 3. I'm going down. And to actually get to the point, I have to go 1, 2, 3, 4 to the right. And you're gonna notice you actually get the same exact answer. So some students really like using the formula every time. If you get a graph and it's something that's easy to count, then that's also something that you can do. Now, a lot of times we'll do that. We can also use slope formula, not just to actually calculate, or in this case, it's going to say find the rate of change. And as soon as you see find rate of change in your mind, that really means the same thing as just slope. So again, I usually start by labeling them. I have my x sub 1, y sub 1, x sub 2, y sub 2. You could flip these names if you really want to. Again, that part doesn't matter. You just need to make sure that your points, the x and the y, if they're from the same ordered pair, they have the same number with it, okay? And I'm gonna plug everything in. So slope formula tells me that we are gonna do, and I'll rewrite it down here, y sub 1 minus y sub 2, oh my goodness, over x sub 1 minus x sub 2. So what we're gonna do is we're gonna plug everything in. The minus sign actually stays though, so I'm gonna kind of keep that in there for right now, and I'm gonna plug things in. Y sub 1 comes first, and our y sub 1 is -1. Y sub 2 is gonna end up being, oops, and I deleted that. That's gonna end up being -1. And x sub 1, I'm gonna move down to the denominator, that becomes -3. And our x sub 2 becomes 5. Now on the top, if I do 1 minus -1, those actually cancel and you're left with -1 plus 1, which is 0. -3 minus 5 ends up being -8. And if we actually reduce those, 0 divided by -8 ends up being 0. So what that just tells me about this line is that this line just doesn't, it's not increasing and it's not decreasing. Cool thing is if you were to graph these points, if I go left 3 down 1, and right 5 down 1. If you guys notice, if you graph that line, you're gonna notice and see that this is actually that case. It's not increasing, it's not going up and to the right, it's not going down and to the left, which means that's a perfect example of a case where your slope is 0. So I'm gonna give you guys a challenge problem. I'm gonna have you guys, or actually, no, we're gonna do this one together. This is actually a really good example, though, of a problem where you don't necessarily need slope formula to solve for a slope. Because there are cases where you might be missing an ordered pair somewhere along the line. So this is a case where I know it gives me my points. So I have x sub 1 and y sub 1. And I am missing my second x pair. Which means, though, that's okay, because they actually gave me this slope formula I can also use to kind of reverse the process. If my formula normally is m equals y sub 1 minus y sub 2 all over x sub 1 minus x sub 2. If that's my formula, let's plug in everything that we know. We know that my slope is gonna be 1/2. And if I keep going, I'm gonna plug everything in. Y sub 1 is going to end up being 3. It's going to be 3 minus 2. And then on the other side, oops, sorry about that. And then on the bottom then, I'm going to do x sub 1, which is 6, minus x sub 2. Even though we don't know what it is, we're calling it r in this case. Now, if we go through and simplify, we have 1 over 2 equals 3 minus 2 ends up being 1. And on the bottom, we have 6 minus r. Now you're probably looking at this and you're saying, Ms. Hardy, how do we even go about solving this? And the cool thing is you guys already know how to solve a problem like this. We currently have, think about this, we have a fraction equal to a fraction. How do we solve any kind of those problems? Well, we cross multiply. So that's what I want you guys to do right now. Pause your video and I want you to try cross multiplying here. All right, hopefully you got your answer of r equals 4. Let's think about how that happened. So on one side of your equal sign, you should have 1 times 2, and that would have put on one side. Second piece is if I do 1, now just be careful to make sure you put parentheses around this, but if I distribute the 1 to each of those, we're just left with the 6 minus r. And then it's just a matter of solving. I subtracted 6 to the other side, and then I divided by the -1 that was in front of the r to get r alone. All right. So guys, obviously if you have any questions, feel free to ask. If you would like to, now is the perfect time to pause your video, and I'm going to write in the answers to the You Try Nows below. All right. Hopefully you got those answers. If you did try them, if you don't try them, no worries. We are going to go over these together as a class. All right. All right, guys, good luck. You guys can move on to the homework for the day.